people can watch per their leisure tomorrow and later tonight. But yeah, so I think for now we'll stay in the same Zoom call, not breakout rooms yet. But if any of you have any pressing matters that you need to attend to later, one of us can join you in a separate breakout room to quickly resolve whatever confusion you have and then come back here. And yeah, I guess that's basically it. Be patient with us and let's get started. All right, so just like raise your hand whenever you have a question or anything.
I had a question. In the fall 19 practice midterm, there was a pretty brutal question about like what would Python do. If you put it into PyTutor, it ended up spitting out about like 12 frames. I was wondering like if there are any tips on how to kind of go about a question like that, since I don't think I would have the time to really, do that.
Okay, so let me go to the question at hand. So what exam did you say again?
The fall 19,
Okay.
question 1, I guess part 4. I can also screen share if that's more convenient.
Yeah, that would be great.
Okay. Where'd it go? Just had it. Can you see that?
Yeah, I can see it.
Great. So is this last one right here, Pumbaa on Timon on 5?
Oh, this one, the
Oh,
infamous
God.
Pumbaa Timon question. Okay.
That was
So this was regarded as one of the hardest questions on this test, and when I took it, I'm going to be completely honest, I did not know how to approach it even in the slightest, because you look at it and you're seeing that it's a function calling itself on an x that's returning a lambda from the original function. So it's a lot to take in. But I think what we need to look at foremost is just the bottom section of the code, starting from Pumbaa equals lambda f, lambda x, f of x, so on and so forth. So in essence, what we're doing is we establish lambda f, and that should return another function, lambda x, right? Whose result return value is f of x. And then we see that Pumbaa is reassigned to the result of calling Pumbaa on Pumbaa, meaning our f in the initial call is going to be the function Pumbaa. In essence, we're doing Pumbaa of lambda f returning lambda x that returns f of x. That's a lot to keep in your head, and I don't expect most people to actually get this question right because of the sheer number of frames that you have to draw out. I personally would do this through inspection. So you look at the next question and you see Rafiki's 1, right? Don't worry about that for now. And then Timon is lambda y, y plus Rafiki. But then Rafiki is set to -1. And I think a lot of people make the mistake of looking at the initial definition of Timon, and they reference what the value of Rafiki was when they first declared Timon. The issue with that is when Rafiki is redefined as -1, we're going to be having a different value. So I believe the answer to this question, as far as I remember, I think it was 1.
That's correct, yeah.
The reason being, so if we're calling Pumbaa on Timon, we know that the Pumbaa function is called on itself. So we can assume there's going to be maybe 4 calls to the inside or whatever function we pass in. And we saw that it's Timon. So just based off purely off inspection, what I just guessed entirely, I'm not saying this is the right way to approach this, is I knew that I would be applying Timon 4 times based off of the fact that if there's an f of x as Pumbaa, and we call x to be, or sorry, not x, f to be Pumbaa again, it's going to be like 4 layers of f. That was just a guess that I had. And based off of that, I knew y is going to be 5. And then we would have to apply Timon 4 times. So I simply added the value of Rafiki to whatever our y was, which is 5. So I went from 5 minus 1 to 4, 4 minus 1 to 3, 3 minus 1 to 2, and then 2 minus 1 to 1. And that's how I approached it. I would say that's not the wisest decision to make. I don't know how Sandhya solved it. Do you have anything you would recommend?
I think I would probably take a similar approach in terms of like doing it through inspection. Obviously, because trying to keep track of all the individual frames for this problem would probably be quite confusing and a little bit of a headache, honestly. So I think similarly, I would just really take a look at how many times the Pumbaa function is being called, kind of like Arjun mentions, keeping track of the fact that if you know it's being called on itself and essentially yielding 4 calls, that's one way you could essentially take a look at the Pumbaa to Timon 5 section without needing to necessarily draw it all out over and over. So again, problems like this are generally going to be at the end of your environment diagram questions. So if you really find yourself taking like 10 minutes or like any ridiculous amount of time on this problem, it would definitely be worth it to consider going through the rest of the test and coming back to the problems like this later if you find yourself really having a hard time. Because again, there's going to be a lot of points to be had on the test, and you really don't want to like stay on one problem for an extended amount of time. But yeah, if you really do want to stick with this one, then don't try to get too bogged down in every single frame, and just try to have like a very high level look of how many times the given function is being called.
Completely
Great.
agree. Yeah, also, just to reiterate the fact that this is a hard problem. My roommate is quite literally a computing genius, and he struggled with this. So if you don't get it, it's completely okay. Most people that I know of solve this through inspection. So that's the way I would suggest. All right. Next question then. From Daniel.
How I think was first.
Oh.
Oh no, my question was just the one that was
Yeah.
asked.
Oh, right on. I watched the video for, I think this is spring 2020. I can pull it up if you want.
Sounds good.
Let's see here. Cool. Where screen 2? So the video publisher or whoever was running the video at the time, they went through like a mathematical way to solve this, because after a while there is obviously a pattern, but I just didn't quite understand how to do this without iterating it through like 100 times until you get to like greater than 100. I was wondering if you might help me break down how to mathematically do this instead of taking up a whole sheet of paper and running through all the values.
Okay, let me take a look at
Yeah.
what this does. So just analyzing it, we know our talk value is going to be 50, and then tick is assigned to a function that returns talk plus 1. So on our first call, it would probably return us 51. And while talk minus calling tick, the function tick, so we're calling it, and then is less than 5. So talk in our first case is still 50, and then we're reassigning tick to, in our first case would be 51, So 50 minus 51 is -1, which is less than 5. Talk is assigned
Real
to,
quick.
Yeah.
So when you call tick, it doesn't add another. So it would be 50 and 51, not 52.
not 52
Okay.
because we didn't call it the first time. We're simply
Then
assigning
what?
tick.
Then why not just have talk minus tick? What's with the open parentheses? I don't understand it.
The open parentheses is the call expression. So in the second line, we're establishing the name tick, like assigning the name tick to the function that takes in 0 arguments and returns the result of adding talk plus 1.
Okay.
In the third line, we're basically doing a condition where the talk value that was passed in, 50, is subtracted. We're subtracting the value of calling tick, the function that we established earlier, and comparing it to 5 to see if it's less than that. And so we see that 50 minus 51 is less than 5. So talk is reassigned to another call of tick, 52 plus 1, so 53. And then if 53.
Wait, I thought so. So talk wouldn't equal. Why wouldn't talk equal 51 in this case then? Or yeah, or no, 50. So talk would equal 52 then.
Talk would equal. The reason being, I might be wrong in saying
Like
this.
50, 51. Or no, I'm sorry, talk would equal 51 here.
Oh wait.
Also, the tick and talk thing is throwing me off like mad.
It's
They're
okay.
like, hey, make sure you name your variable so you can distinguish, and they throw this bullshit at us. Like, I'm sorry. Like, really? Like, are you freaking
Yeah.
serious?
That's one of the fun parts of 61A. They really love tripping you up with variable names.
Oh my god. Oh god, there's one where it's like Q of Q, comma Q. I'm like, ugh.
Honestly, one thing that I might do for problems like this is just like when I'm like drawing out or thinking about it, I would like, I mean, you can like mark up your test papers. I would probably like scratch. Honestly, I would like consider scratching out or like at least like mentally renaming the variables just to like
Yeah.
substitute them with something less confusing.
That's
Because
a
yeah,
good idea.
I would definitely be getting, because I remember when I like did this problem, I was like lost between tick and talk for the longest time.
That's completely understandable. In fall of 2021, they had another TikTok problem, like question, because they apparently love TikTok so much. But yeah, I mean, I guess the reason there's different values of tick, or at least I think there should be. I don't know. Is that the case? It actually might just be 51. I'm not sure. Because so numbers are primitive values, and primitive values typically are not mutable, just inherently. So let me do one thing really quick, and I'm just gonna check before I confirm. Though, Sandhya, if you could work through it, if you do know the answer, or like how to work through it, I guess.
Give me 1 second. I just want to confirm the answer as well.
Yeah.
This is, what year is it again? Spring 20? Okay.
Spring 2020. Yeah.
It's 103 if you need it.
Also, I hate how long these freaking videos are from the TAs. I'm like,
Yeah.
longer than
They're helpful, but if you're like cramming, then you want to be able to get through it quicker, I assume.
Yeah. They also use it as justification to say, look, if we can do it in the time frame of the test, you should be able to do it. I'm like, no, you have the answers. Okay, yeah. So I believe I was mistaken earlier. Was I? Yeah, I was slightly mistaken, though I am glad I clarified this. So basically, like I said, the tick value is going to be looking at the same talk given that integers are a primitive type. And you'll learn more about mutability later in the course, but essentially take it as that if you call the function tick, talk increases and that's what's returned, but talk itself is not being changed. So in the first tick assignment, it's a lambda that returns talk plus 1. And then in the third line, we're taking 50 and subtracting calling tick, which will return us 51, given the current value of talk is 50, and that's less than 5. So when we call talk is equal to tick, like calling tick plus 1, the value of talk is still 50, and then we add 1, and that becomes our new value of talk. So it becomes 51. And then we check if 51 is greater than 100. It's not, so we skip it and then return talk. That's a while.
Are we sure though? Because wait, so right now it's 51.
That's 51.
So if we do 51 plus 1, then it's 52.
Oh,
No?
sorry. I keep making
just making sure. No, I was okay.
Yeah, it's 52. And then we keep going through the while loop. So now talk is going to be 52. And then when we look at tick, when we call it now, it's going to be 53. Or yeah, when we call tick, should be 53. And then 52 minus 53, I believe, is still -1. So that's less than 5. And it keeps going through this because you're always going to be like 1 less than the new value of tick. So I believe once you're all the way at the end, when you call tick, it should be, what value is it again? Keep going until talk is greater than 100. I feel like I'm confusing myself unnecessarily right now. So -1, that becomes 52. 52 is not greater than 100. Goes back. Tick is 53. Talk is 52. -1 keeps going.
Quick question: what's the final value that's returned? Like, what do we know the answer is for sure?
Let me quickly check. The answer should be 103.
3. Okay.
So calling tick increases that by 1. Keeps going until talk is greater than 100. Okay. I think one thing we can do is observe the state of where this is going at each step and basically make a mental jump about kind of where it would be maybe in the future. So I'm just going to annotate really quick. So at the very beginning, we have talk is equal to 50. And then we know tick in the first run is 51. While talk, which is 50 minus 51, this results in -1 is less than 5. Talk will be reassigned to 52. And 52 is not greater than 100, so it keeps going. And so our final state for talk here is 52. And our tick at the very beginning is 51. So based on that understanding, and the fact that the answer is 103, we can take a jump perhaps to the case where tick is 99 and talk should be about 100, I think. $52. Am I right in saying that, Sandhya? I'm not entirely sure.
Yeah, no, so far that lines up.
Yeah.
If we get to 99, you just mentioned doing while 99 minus 100, I believe, since you're incrementing talk is less than 5. So essentially that condition is always going to be great. So I think the while talk minus tick condition is less than 5. I'm pretty sure it's always going to be true. So you're always going to be moving on to the next line.
Right.
So if we assume that talk at this point is 99, we'll be incrementing that to be talk is equal to tick plus 1. So talk is equal to tick plus 1. If we know that talk is 99, that'd be incrementing up to 100. Now we'd be getting 101 from that. So talk could be set to 101. If talk is greater than 100, return tick. At this point would be greater than, I'm just like talking to my process right now.
Yeah.
If talk is greater than 100, which at this point would be, we'd be returning tick, which at this point it's 101. Tick is equal to lambda talk plus 1, which is going to give us 102. How do we get 103?
Also, just to justify why we're jumping ahead. So if you notice, if we run through this once, our initial value for tick, or at least our value for tick in this case, is 51. And then talk at the end would be 52. Then if we start the next run, this is actually set to 53. This becomes 54. And then you can just keep counting from there. So 55, 56, 57, 58, 59. And that's one way of going through and seeing what the number is going to be. And then once you finally reach this case, you can kind of proceed from there. So I'm just going to count out quietly to make sure that 99 is the initial condition for tick, but yeah.
Sure. Generally, if you guys see like an identifiable end pattern, like we can see in the third line, while talk minus tick is less than 5, we know that's never going to evaluate to any other than true. So you'd want to keep looking to try and see at what point in your code can we extrapolate for there to be actually some sort of valuable condition to check for. So if we see if talk is greater than 100, you know that you're going to be getting your actual return value sometime after that. Since we know that otherwise, just going to keep looping in a way. So that's why we're just trying to figure out what happens when you get to 99, since that's what actually gives us that talk value that's going to be above 100.
Okay, after some counting, I realized that in the part that we need to look at, our initial tick is going to be 101, because in the call before that, this sums up to 100, this part. So it's not greater than 100, so we go through this again. And so this starts at 101, and then this one should add 1 to talk, so it becomes 102. And then, since talk is reassigned to 102, it is greater than 100, and then we return tick. Tick, calling it on the current value of talk, which is 102, adding 1 gives us 103. I know it seems like a big jump where we went from this to that, but honestly, what I would recommend, once you notice the pattern, just count the numbers in your head of what the n numbers or values for tick and talk at the end of each call. And then start looking once you finally reach the point where you're nearing this, then start doing it like verbose, like writing it out again, because that way you can keep track of, oh, where's this number supposed to fit in? Like, when is this finally going to be over 100?
You guys just made the math click, actually. The Video did. Okay, so that's why. So essentially, the video noticed that there was like a differential of 2 between the two, like tick and talk. And so she was like, okay, so well, if we know that, then 50 plus 2x greater than 100, that should be like, I don't know, somehow it evaluated to like, what was it? It was 26 iterations before it was greater than 100. So this would be 26 plus 50. No, wait a minute. 26, no, 26 times 2 is 52. I'm sorry. So then that'd be 52 plus 50 greater than 100, right? That's 102. And that'd be the value. And then that's the value that kicks us into here, right? But then we still have to add 1 because we're calling tick, which would then equal 103, I think.
Yeah, that's a
Yeah.
completely valid and probably better way to
Okay.
approach this.
I think it makes a little more sense now.
Yeah, the
Uh-huh.
issue with that, right? At least I think, is most people don't have time to think about where an equation should begin or end, and like
That's what I was
especially
confused
in a
too. I was
test
like, what?
environment.
Yeah.
I was like, why are you bringing algebra into this?
I mean, I can't speak for the whoever made the video, but I personally would not be thinking about equations when solving this problem.
Yeah.
So this, I would say, like, if you do have like the bandwidth to do some of this during the test, then like honestly, hats off to you, and definitely this is a definitely valid method to use. If you're sadly in a more stressed out mentality, which is where I know I wasn't taking the midterm, it might be worth it to just try and like do what we just did here in a way. So identify like a recurring pattern, see if you can take that pattern to its natural conclusion within any of the if loops or while loops within the actual question structure, and then try to use that ending condition and try and like derive what your like final value would be. But again, there's a lot of different approaches you can take to 6 to an 8 problem. So honestly, just based on whatever practice you've been doing, just identify what works best for you and see how you could apply that.
I agree. All right, Pooja, you're next.
I had a question on fall 2021.
Mhm.
Yeah.
I think it was number 1, part 2. I'm confused on like why J would be 6, or sorry, why J would be 8 and not 6.
If you have it open, is there any way you could share your screen just so like everyone can like see which problem you're referring to?
Okay, yeah, I'll have to switch to my
okay.
other device. Give me a
Pooja,
second.
I can share my screen if you want, so it can
Okay,
also
yeah,
be
that would
easier to
be
draw.
helpful.
Because I can draw it out for everybody.
Okay,
So
thank you.
yeah, no worries. So okay, I'll put this to the left and this to the right. So we're gonna draw each of the values and see how they change. So what I like to do is kind of just have this in a environment diagram format of designing. I think most people's first intuition should be to try and do these kind of questions in environment diagrams. So let's define os, which is a function os that takes in key, and its parent is g. Okay, and then we don't go to the inside, like the suite of the function, because it has not been called yet. So first, we just simply make I, and we assign it to its initial value of 5. T, assign it to its initial value of 7, and we look through the loop. So let's start with while I is greater than 3. We see that 5 is greater than 3, so we execute the suite of the function of the while statement. And we see that t is equal to I minus 4 and I plus 4. Now, if you remember, and looks for the first false.
Mhm.
And if it finds no falses, it'll return the last statement in the comparator expression. So we see t is equal to I minus 4, which is 1, and I plus 4. We see that there's no false values. In terms of integers, the only false value is 0. So we actually return the last expression. So we reassign t not to 3, but, or sorry, not to 1, but rather 9. And then we call Oz on I minus 2. And I'm just going to do this for the first case of this. But F1 Oz P is equal to that. And then key is assigned to I minus 2, which is 3. Because we look in the global frame and we see I is assigned to 5. Therefore, key is 3. And then t is -1. So most people make the mistake of seeing the t. They're like, oh, I made a t earlier. It's in the global frame. This is not making a reference to the t in the global frame. This is creating a t and assigning it to the value of -1 in the local frame. So it's basically doing this. There used to be a concept taught called non-local, which would basically access t's outside the local frame and reassign that if you did something like this. However, we're not learning about non-local, and I don't believe it's in scope for you guys, so you can just completely ignore it. And we see that os doesn't have a return value, meaning by default, it has a return value of none. So essentially, this does nothing. We don't need to worry about this any further. We're not going to be drawing any more frames for this because it's essentially pointless. So we go to the next line and we see it's a parallel assignment statement where we're reassigning I and j to the results of I minus 1 and I star 2. First thing to keep in mind when you see parallel assignment, evaluate the right side before ever touching the left side, because we're essentially wanting to see what the values are in that moment before changing the values I and j. Because you see, if we did something like I is equal to I minus 1, then the result of j would not be representative of what the original value of I was times 2. So we evaluate the right side first. And we see I minus 1 should be 4, and I times 2 should be 10. But here's something. We don't have a j defined in the global frame. We have to create one. So j is created. And we saw that because I minus 1 is 4, and then I times 2 is 10, we assign both at the same time. So that's 10, and this becomes 4. And then we see s is equal to I. So we create a new variable and we look at I, we see it's 4. Boom. Okay, so we have done one iteration and we have to keep going until I is not less than 3.
So
while
when we have I and j, like I comma j, and like we assign two variables, I guess, at the same time, we look at the old value of I, so like it doesn't change. So like we do like I minus 1, so that gets us 4. And so do we not do like 4 times 2 for j?
No. So the execution procedure for parallel assignment is evaluate all the things on the right side of the assignment statement, and then assign each individual value on the left to the corresponding value on the right. The reason this is useful is in cases where you want to basically swap the values. So if I was to tell you, like, this is just a theoretical case, if we have a certain number of sheep and certain number of wolves. And we want something so that the number of sheep becomes the number of wolves, and the number of wolves becomes the number of sheep. Essentially, they're swapping values. So that's the reason parallel assignment is so useful. Is we can do something like sheep, comma, wolves is is equal to wolves, comma, sheep. Because we're looking at the original values, we evaluate them, we see that sheep is 8, wolves is 7, and then we assign the corresponding values to the ones on the left, and we see sheep is equal to wolves, the original value here. So this becomes 7. At the same time, wolves becomes 8, which we already evaluated. So this becomes 7, this becomes 8. And that's the reason parallel assignment is so useful. In programming languages like Java, you have to actually have something called a temporary variable that will store the value of 1, and then you have to swap one for the other. And then the one that's been swapped, you set it to the temporary variable value. And that gets very messy and causes you to have these unnecessary temporary variables when Python has this beautiful thing, parallel assignment. So I'm a big advocate for using parallel assignment whenever you can. God, the erasing tool on this is just absolutely horrendous. I'm gonna, whoop. Anyways, going back to the problem. So we've gone through one iteration and then we go to the next one. I is still greater than 3, so we go on, and I minus 4 is 0 for this line. T is equal to I minus 4 and I plus 4. But I minus 4 when I is 4 results in 0. 0 is a false value and returns the first false. So T is set to 0. And then we do Oz does nothing, as we established earlier. And now we're doing the same parallel assignment shenanigans we did in the previous part. I minus 1 is 3. I times 2 is 8. So this becomes 8. This becomes 3. And then S is equal to I, which is 3. Beautiful. Now we recognize that I is no longer greater than 3 at the beginning of the next iteration. So we have finished executing. And now if we look at the answers, what value is bound to I? Well, it's 3. For J, it's 8. For S, it's 3. And for T, it is 0.
Thank you so much. Yeah, that I guess like my area of confusion was the parallel assignment part, but now that makes sense.
Yeah. So just keep in mind the execution procedure for parallel assignment. Execute all or evaluate all the values on the or expressions on the right side, and then assign them to their respective counterparts on the left. I got a DM from a few people. Sorry, I didn't notice these earlier. I'm just going to address them now. Would it be different if it was I equals I minus 1 and then T equals I times 2? Yes, because in those cases, we are having individual assignments and one has to finish evaluating before the next one can be evaluated. So in the first case, if I was 5, our first statement would be I is equal to I minus 1, which would reassign I to 4. And then evaluating T is equal to I times 2 would actually give us 8. So that's why that works. And then I got one earlier. So even though Pumbaa is called in the second row, we use -1 for Rafiki. The reason we use -1 instead of 1 is, again, in reference to global frames and local frames. When you reassign a variable in the global frame and a function references that, If it's not in the local frame, it'll look at the current most value in the global frame and take that. The only thing that it preserves are things from what is passed in, and especially mutable types, because those stay the same between classes, and mutating them in the function will actually reflect in changes in the global state as well. So that's because of something that you'll learn about in 16b known as addresses and where those point to. But yeah, why is it 0 but not false? Good question. So the reason it's 0 but not false is because of the fact that 0 is a true value, or falsy value, I guess, in this case. And the reason is, I guess the easiest way to explain it is the fact that and or statements return true and falsy values rather than just true and false. And when you put those true falsy values in something like an if statement or a while statement, it'll recognize that this is a falsy value and treat it as a false, but it actually returns the value itself or the evaluated expression. You got anything to add, Sandhya? Any questions that you had to answer?
I think in the chat there was a question about study guides. For me personally, I just put like example problems or concepts I want to be able to reference, and like syntax notes. If there were often like bits of syntax, I often got mixed up. I think one thing that really helped me is just being familiar with my study guide going in, because I think for midterm 1, I spent like much longer than I should have, just like looking through my own study guide to like remember where I put things. So that kind of familiarity can really help save time. Same thing goes the study guide they'll give you. I believe they should have posted on Piazza or the like. Definitely take a look at that, just to like go over like concepts they'll have in the midterm, because that thing is incredibly helpful. Like if it's on the study guide, it's generally good to be familiar with that concept. So just take a look at that as well beforehand. Yeah, so it's in the chat right now. So just make sure to take a look at that so you know where everything is and that you're familiar with everything on it. Arjun, if you had anything else to add on yours.
Yeah, what I would say, personally, a day or two, writing up a comprehensive cheat sheet, as they recommend you have a double-sided one-page cheat sheet. You don't want to fill it with information that is already on the study guide they provide you. That is redundant. What you want to do, from my experience and the recommendations of many people that I'm surrounded by, rather is have a study guide full of examples from previous tests. Usually, a lot of the concepts on these exams are the same between tests. And if you have an implementation that you find in a previous test that you found particularly tricky to solve or you couldn't solve it, having the answers right there in front of you to just plug and chug the same kind of form or understand how this is functioning relative to a previous example can be extremely helpful and reduce the amount of time that you're spending on these problems. Besides that, I would say these study guides should have tips for what would Python do, just general things that a lot of people forget when in a stressful environment. And one thing I cannot emphasize enough, practice tests, do a lot of them. I know the test is in like a day and a half at this point, but do practice tests. I did maybe 7 before midterm 1, and I won't promise you that you'll get incredible scores your first like 3 or 4 times round, but coming from me, I got essentially like 50 and 60% on my first like 3 or 4 practice tests. And on the actual one, granted, it was an easier midterm, I ended up getting a perfect score. So just practice, practice, practice. Look at the TA explanations, however long they must be, and just learn the content for the sake of understanding it rather than the sake of trying to blatantly memorize these kind of useless facts that you can honestly just have on a reference. But yeah.
Yeah, really following up on that. Definitely just take a look at practice tests, try to find recurring patterns. I thought that for a lot of 61A, it came down to pattern matching in a way, finding problems that reflected strategies you were familiar with and seeing how you could modify or apply those. I neglected the value of practice tests in studying for my first midterm. I really did not do as much as I should have and did not get the score that I wanted to. So for midterm 2, I really crammed like 7 or 8 practice tests and really saw like a noticeable improvement. So really seconding what Arjun said, the fact that you're coming out to these study sessions is already really, really good. It shows that you guys are really like dedicated, which is amazing. And just making sure that you guys like do practice tests, do past midterms. Those will really help you be able to recognize the patterns that you'll need to apply for midterm 1.
I can also very much suggest the value of CSM. I was in the CSM section. Granted, I didn't attend a lot of the meetings because of conflicting times, but attend those. They have really useful study guides. The mentors are really nice and they're willing to help you out even past your designated times. And please ask questions. Questions are the way you understand content. I bugged my roommate for days before the midterms, and it helped me a lot because he has a lot more experience than I do when it comes to programming. But asking questions to your TAs, your instructor, going to office hours, things like that, they make a significant difference. And no matter how much experience you have, there's nothing that can't be overcome with purely hard work. And I mean that. There's luck is a big factor, but dedicated effort, despite experience, will pay off a lot more in the long run. And if it serves to be a model of inspiration, I know people that came into 61A with probably like a few months of programming experience, and they ended up doing better than a person who's literally been programming since they were in elementary school. So yeah, that's what I will say. Don't be too nervous. I know that's easier said than done, but this exam is not going to be the end of things. I have seen people get less than average on the first midterm and then literally get like near perfect scores on the final, out of nowhere too, just through grinding out practice tests. So it can be done. Don't be too harsh on yourself. It'll be okay. But yeah. Now that we've had our little moment of encouragement, are there any more questions? It can be about anything, including labs, homeworks, whatever. What's considered average on the midterms? I believe it's 60%, 65%, something like that. Yeah, it's pretty low, but you know, if everyone does that bad, it says a lot how much, like, if the class average is a B plus despite 60% averages, I think you guys will be fine. I'm low-key worried I won't pass the class. What score should I be aiming for on the midterms? To pass the class. Well, I'll say this. It's very difficult to fail 61N. Like incredibly difficult. I feel like if you even do the bare minimum of just, studying like 1 or 2 practice tests or anything, I think even a B is like very easy to do. But don't worry about passing. I think you should really focus on doing the best you can do. And I'm sure that the projects and stuff will carry your grade regardless of how you do on the exams.
So all that to say, don't view midterm 1 as like a make or break for your grade, because it definitely isn't that. Like Arjun said, if you're putting in the work to study for the exams, which I mean you guys are doing right now, it's showing up, you guys are definitely going to do well on midterm 2. I mean midterm 1. Like, and even if you get a grade that you feel like you personally aren't satisfied with, you definitely have a lot of room for growth in terms of midterm 2, future projects, and the finals. So there are definitely still a lot of points left to be earned. So I personally would try to approach this midterm with just trying to like take the knowledge that I've learned and apply them to the problems in the midterm rather than spending it for like stressing about the amount of points they want to gain, if that makes sense.
Yep, 100%. Clobber policy for exams. There is none. There is no clobber. Unfortunately, that is a EE kind of policy, I believe, mostly. EE 16A will offer clobber. This is a strict do or die class. I know it's very sad, but it encourages you to focus on every part of the class and not keep things till the last second, which I think you'll come to appreciate near the end of the class. But in the beginning, it can definitely be annoying. What's the lowest we can get if we want to declare CS for, what's M1?
You mean for midterm 1?
Oh, if we want to declare CS, oh, the lowest you can get.
A 0. In all honesty, like even if
Yeah.
you don't perform all that well in midterm 1, you have a lot of chances to bring your grade up later on. And 661A is definitely not the only class you're going to be taking. So even if you feel like you didn't perform as well as you wanted to overall in 621A, you still have 621B and 70 to implement better study strategies and try to bring your GPA up there. So again, please don't view midterm 1 as like a make or break for declaring, because I promise you'll have a lot of opportunities in the future to bring maybe your grades up to where you want them to be and secure the ability to declare. So please don't panic about declaring for one midterm.
Also, just to be not a pessimist, but a realist in a sense, 61A is the middle ground when it comes to the declaration courses. It's not the hardest. 70 is by far the hardest course. It will make you cry. I'm not kidding about this. I'm not going to underplay it. I'm not taking it right now, but most of my roommates are or have. It's a struggle. 61B is very doable to get an A. They have very lenient policies when it comes to homework, projects, all that kind of stuff. So that shouldn't be too much of a, a painful experience. 61A, don't worry too much about your grade. But I would say if you want to, I'm not speaking for just midterm 1, but I'd say overall class grade. If you really want to make your life doable for like to declare, I'd say you'd want to get at minimum a B. But a B minus is possible. You just have to do very well on 70 compared to say someone who gets an A in both 61 A and B. That's like you can get like a C minus or something on 70, which sounds really nice. So it's up to you how much effort you want to put into this class to get like a higher grade as a buffer for 70, because I know that's gonna crush a lot of people's hopes and dreams. But low-key put on a wig and take it for me. You don't want me taking your exam, trust me. With how much I remember from 61A, you don't want me to do it. But yeah, are there any questions from like homeworks or labs or anything? I would love to answer some.
Or even just like conceptual questions you might want us to go over, just like literally anything.
Yeah.
Yeah, Samia, did you have a question?
Yeah, actually, like, so it's not a homework or lab question, but it's more like a kind of like a conceptual problem I've been having with solving an exam problem, specifically in spring 2021, I believe. I'm also curious about like what constitutes like a good model exam for this midterm, because some people are saying, oh, they had access to an interpreter, some are not from Professor Fox. So I'm just also struggling with that. But anyway, sorry. For spring 2021, my specific question was about number 2B. I think it deals with like a helper function, which is my current conceptual problem, like how to write a how to write a helper function and how it works in the case of code.
You said 2B, right?
Yeah, to be restrict range.
Spring.
The mock midterm for 2021, not the actual midterm, right? Or
Oh no, the actual midterm, pretty sure.
the actual midterm? So spring 2021.
I see
I see the case of the missing doc string on that one.
Oh, yeah,
I might be looking
yeah.
at the wrong doc. Oh,
Yeah.
okay.
Oh no, you're right. I was just like on part B of that problem is the thing.
You're good.
Mhm.
I only see a part A for that one actually. I might be looking at the wrong thing again, but it looks like there's 2A and then it goes straight to 3A.
Oh,
I'm
have I
not
the
sure of the
question number. Oh my
solutions.
lord. Okay, yeah, never mind. This was farther than I thought it would. It's number 4, a domain range. A domain
Okay,
on the
no worries.
range, and the part of that is restrict range, and that's what I was having trouble with.
Okay. Give me just one second to take a look at it.
Yeah, I've been hogging the speaking time too much, so I'll let Samia do this because I feel bad.
Oh no, you're totally good. Don't worry about it. Yeah, I'll admit I'll need a second or so just to look over this. So Arjun, if you have like an idea of what the question is about, you can like get started.
Okay, sure. Let me check it out. So,
I can also like share the screen if that would like be more helpful.
you can if you'd like. I have the answer key pulled up just to make sure I understand the process. But
All right. Well, yeah, I think I'd prefer to share the screen then to like walk through the logic and everything.
yeah, sure. Go ahead.
Okay, yeah, go for it.
Of course, Pooja.
Okay. Yeah, of course.
We'll probably hold something like this again before midterm 2.
Yeah, for sure. Okay.
This is a long exam.
It definitely
Yeah.
is, especially with the multiple choice.
Yeah. Yeah, this was important.
Okay. So for strict range. Okay, so do you just want us to go over the entire problem?
Yeah, that'd be
okay.
Cool. Yeah, just like the
Okay,
logic
sure.
on how this was done.
Of course, no worries. So generally for these problems, the first thing you want to do is just take a look at the doc string. That kind of tells us what the input and output is going to be, what the domain and range for our function is, and what type we want to make sure we're returning here. So in this instance, we're returning a function that restricts the range of f, a function that takes a single argument x. If that return value of f of x is not between low r and high r inclusive, it returns negative infinity. Otherwise, it returns f of x. So the first thing I notice here is that we're returning some sort of function. And we see in the very last line that we're saying return wrapper method name. So you can infer from that wrapper method name is going to be whatever function you're trying to return.
Gotcha.
Right. So in this function, we're going to be essentially defining whatever we're returning, whatever function we're returning, and then spitting that back out. So from that alone, that would sort of drive me to seeing that blank A, since that's the very first line, and it looks to be indented further in than the others. Like the way you define a function is you have your first line stating the function name, and then so everything below that would just be indented. So based on that definition alone and the indentations of the function, that would drive me to assume that A is going to be actually defining wrapper method name. So that would drive me to think that part A would be defined wrapper method name. From there, we know that the function we're returning is going to be restricting the value of f. Right. So give me just one sec. Returns function that restricts the range of f, a function that returns a single argument. Okay. So we know here that what we're going to be doing is we want to compare our return value from running this function to whatever range that we take in our original function, in our external function.
Yeah.
Right. So the first thing you want to do is we want to store that value, store whatever the actual return value is to compare. So that would make me think that since we're going to be comparing it to a certain range later on, we'd want to start out by assigning whatever the function's return value is to a variable. That'd be the first thing that I'd be thinking of there. So in blank B, do you mind if I ask you, what do you think you might want to be doing in blank B, given that blank A is going to be defining the function? Like, what would your potential first step or first approach be for part B?
I think it's just like assign a variable with like a name that says like the result or something, or like X maybe. And then
Exactly, yeah.
and we can assign that to like the function that's going to be coming out.
Exactly, yeah. So if you check the answers, that's actually exactly what you want to be doing. So for part B, it would be result, or really whatever name you want it to have. Result is going to equal f of n. So that's the first thing you want to do with our function. We wanted to know what the result of f of n is going to be. So you'd want to hold that in a variable.
Yeah.
The next thing that we want to do according to the docstring is if the return value of f of x is not between low r and high r inclusive, then returns negative infinity, but otherwise returns f of x. So the next thing that I would want to think of is trying to approach the if the return value is not between low r and high r. So essentially what that would look like to me is just running a comparison check with the function that we're holding our result variable. So given that, how do you think you might want to be running that check in line C? Like, do you have any ideas on how you might want to structure that?
Oh yeah, I think so. I think this is when that we bring in the conditional, right? Like whether like if our variable result is less than like one parameter of the original function, I think is less than like low r or more than high r, then negative INF comes out, like negative infinity comes out.
That's exactly it. That's exactly it. So for part C, you would want to be checking to see if it's either less than the lower bound or higher than the upper bound. So if result is less than low r or result is greater than high r, then like you just said, you'd want to be returning float negative in, which just returns negative infinity. Just checking in with everyone else. Does anything we've said, like, does it all make sense so far? If you guys want to raise a hand, if you have, okay, cool. And the very last line, do you have an idea, Mikey, what you might want to be doing there at the very end of your function?
I think like at the very end, like it'd be label E. I think label E is going to be return a result, right? Like what happens to our variable, like the one we stored.
Exactly. So that's exactly what you want to do with the last line. You want to return results. Yeah, so I think generally for problems like this, and how you set up and structure your own functions, the way I like to go about it is just like what I just did here, just go through the docstring to try and find like a logical order. Okay. And from there, see what I need to set up a variable and just work through the logic that's sort of given in the docstring. Yeah, so does that make sense? Do any of you guys have any questions about that problem? Okay, cool.
And that was super helpful. Thank you so much.
Yeah, of course.
All right. Do we have any more questions? It can be about conceptual stuff too. If you're not completely understanding, like, oh, how does currying work? I would be more than okay with drawing it out and kind of making more sense of it, because I know that's one of the parts that most people get confused on. Go ahead, Jennifer.
Yeah, Jennifer.
I'm not sure how familiar we need to be with this, but I have troubles with drawing out environment diagrams.
Okay. Okay, so drawing out environment diagrams. So I'll just give you a template really quick of how I like to think about drawing these. So when encountering an environment diagram, for any given code, the first thing that we want to write out is just global. That's the frame that we always start out on, no matter what. When we do this, we assign variables to their values, you know, x5, y7, whatever. We can do functions like, I don't know, potato, and assign it to, you want to use a pointer that points to this, something like func potato, takes in like fry. Oh god, that's horrible. Fry, why is it lagging? And then you just want to put like which frame it was defined in. And then when you call potato, let's say it takes in some argument fry, let's say it's taking in 5 as fry. That's when we have a call expression of some sort like this will be in the interpreter. So if we did potato of x, we would actually, since we're calling it, create a new frame with the tag of the frame number, the name of the function that we are entering, not the name that it's assigned to, however, the name of the function that it is defined as. So if I did something where I was like fun pointing to the same thing, and I called fun of x, the name of this is not going to be fun. It's going to be potato because that's what it was defined as. So that's just one key thing to keep in mind, because you can change the name of functions or give multiple names to the same function, but it retains the same name that it was initialized with. So we create function one potato, and then you just specify parent equal to global, just so you can keep track of it. And then we saw that we passed in x for fry. So we get the fry variable, and we don't assign it to x itself, but rather the value of x. So in this case, it would be 5. And let's say the point of x that they don't show you, or sorry, not point of x, point of potato is something like this, like print fry comma y, something like that. So the return value, right? So let's just say this is the display, like what's displayed from our interpreter. When we call this, it prints, first it looks like the operator of the call expression. We see it's print. So we've evaluated the operator. And next, we want to operate its operands, aka the arguments that we place in for the formal parameters. So we look at fry and we check our local frame to see if it's within there. We find 5. Okay, so 5 is the evaluated value for fry. Then we check for y. We see that it's not in the current local frame. So we check our parent, which is the global frame. Once we go to the parent, we see that y is assigned to 7. And so we can evaluate the result of calling this operand on these specified arguments, which we get 5 and 7 displayed with a space between them, denoted by this comma. And then we notice that if this is the function, we notice it doesn't actually return anything. There's no specified return. So we think about like, what is the return value of a function that doesn't have a specified return value? It's none. So this is just none. And so none isn't printed out or anything. It's not displayed to the user unless you print out the value of none. So if I did like print none this would actually display none on the screen. But if you just evaluate none, it doesn't show anything on the screen. So that's just a side note to keep in mind. But so this whole expression evaluates to simply none. And it displays this. The print function is called a non-pure function because it has side effects. Side effects being things like displaying values or changing some other stuff. You won't encounter too many of those besides print, but it's best to know that non-pure functions have a side effect, while pure functions, typically user-defined, some are globally defined, but will always be pure, and thus they will return a value and not have any side effects, at least typically, and for whatever you're going to be dealing with in the class. And if I had some function being defined here, you could do f2 func name, and then parent is f1, and so on and so forth. And any references you could trace back to this parent and its parent's parent. And that's an essential overview of how these environment diagrams work. Is there any part that you're particularly confused about when it comes to these environment diagrams? Jennifer?
Oh, sorry, I'm pulling up an exam to
Yeah,
find.
no worries. If there's a specific one you'd like us to create an environment diagram for, that would be great. Also, another side note, the recording of this session will be posted on the 61A Spring 2022 server, in case any of you want to go back and look at anything. Sorry if any of my explanations have been confusing at all, but I am trying, so.
Yeah, if you want any of us to like ever clarify something we say, just like don't hesitate to let us know.
I guess in the meantime, can you guys explain currying?
Yeah, that would be fine. Sandhya, do you want to explain it?
Yeah, sure. If you want like me like draw a diagram, I'd rather speak, that'd be great because I don't have a drawing thing set up.
Yeah, I can get the drawing. Just tell me what to draw and I got you.
Okay, cool. So essentially a currying function is Python's, or it's a way of implementing higher order functions. If you take what you might perceive as an average higher order function, so say f of x comma y, that would be a function that runs on two variables, right, x and y. But for certain languages like Haskell, I believe, they don't support multivariable functions. So you would need a way to have a function that can run on multiple variables so that actually taking in two variables. So currying is Python's way of doing that. It's a way of sort of like nesting functions. So in order to curry a function, you would take in a function that acts on the first variable, and then that would return a function that would then act on the second variable. So for instance, let's consider the add function, which is Python's way of just adding two numbers. So if you run add on x and y, that would then return x plus y. So in terms of currying, you want to essentially get a function, you want to essentially be able to run that on both x and y without actually having to write a function or implement a function that takes in two variables. Give me one sec, my computer's lagging just a bit for some reason. Okay, so if you're going to be writing a curry function for this, you'd essentially want to be returning a function that you'd essentially, why is this so laggy? Okay, so in order to write a currying function for add, we'd essentially breaking up the structure that we have here with lambda x is lambda y, and lambda x gives us lambda y, which gives us f of x comma y. So what you would see is if we were to define curry as that entire block, curry is equal to lambda x, lambda y, f of x of y. We would then be able to do curry of one variable. So say curry 5. That would give us a function that then we would input another value in. So curry of 5, which is a function of say 2. That entire expression would overall give us 7, right? Because it's a function that spits out another function that then actually runs the function that we want to do, right? So let's actually try to break down this curry 5 of 2 thing. Curry itself is going to be our lambda x. So right now, curry is going to take in x, which in this case is going to be 5. And then it's going to spit out another lambda function, which is lambda y. So curry 5 is going to give us lambda x. From there, we would run it with 2. So lambda 2 gives us whatever f of x of y is. This entire function would still know what x is this entire time. So it would then give us f of x of y, which is going to give us 7. Let us know if you want us to break it down in a different way. I know that currying can be kind of a weird concept, but basically currying is a way of using nested functions and higher order functions to run a multivariable function without actually taking in more than one variable at a given time. So Miha, I know you asked a question in the chat. Is there anything else you'd want us to clarify for this, or?
Oh, no, like I think it was pretty clear. Oh, I
Okay.
have a question though. What about those functions like that are just blank parentheses? Like what do those represent again? I just keep forgetting that.
So you mean when you have a function name and then just blank parentheses after that?
Yeah.
That's going to be a function call. So having that essentially just tells the computer to run whatever that function is, right? So if you have, I mean, that obviously wouldn't work for functions where you would need a parameter, but generally for functions that take no parameters, having that just tells the computer to run that and then spit out whatever its return value is, right?
Okay.
Whereas if you only have like the name of the function, that's just going to be a pointer to whatever the function actually does, but it won't run anything. You need to have parentheses, and if needed, you need to have parameters to actually tell the computer that you want to run whatever that function is.
Oh, okay, got it. So just like it illustrates like it's like a specific file form and doesn't do anything else. Got it. Thank you.
Yeah, so that's going to be what we call call expression, as you can see written out just now.
I apologize for the extremely bad handwriting, but
No, don't worry. It's totally good.
but yeah, basically the way I like to think about currying is the memoization, which is something you'll learn later, of values and being able to recall values through environment diagrams. So when you have something of this form, essentially, let me change to pencil. So when you have something of this form, in essence, you can think of it as having the global frame, right? You have the global frame, and then let's say you have you have curry, which is this this function, and I'm also just gonna put f, which is just add, and then curry is this lambda x, lambda y of f of xy. So essentially what this is doing is when you call this expression curry 5.2, we look at the operator, which is curry, we evaluate it. We have this function. And then we evaluate the operands, which is 5. And then to execute it, we create a new frame, f1. And the name of it is not curry. This is a lambda expression. So it's actually just going to be the lambda symbol with a parent of global. Here, x is going to be assigned to the value 5. And the return value is going to be the function lambda y returning f of x comma y. And when this is returned, this whole part, curry 5, is this function. That's what this is, because this is what this call expression returns. So you can essentially replace in your head that this never existed, but rather it's this, which you're calling on 2. So we create another frame, f of 2, which is another lambda. Parent is f1 this time, I believe. And then y is assigned to 2. And the return value here is, we know it's f of x comma y. But where are we getting those values? Well, see, we actually have to use the construction of this environment diagram itself to extract them. When we have this return f of x comma y, we have to identify or evaluate the operator. To find the operator, we look in the local frame, we see that f is not defined. So we look in the parent frame. F is not defined here either. We look at that's parent frame and we see it's add. Okay, add is going to be the evaluated operator. Then we look at the operands. Our first argument is for x. Look in the local frame, not there. We look in the parent frame, it's there. So the first evaluated operand is 5. And then we look for y, it's in our local frame. So we're able to put that there. And when we evaluate this, this evaluates to 7, which becomes our return value. And thus, this whole expression up here returns 7. So that's the basic overview of how currying works. It's the manipulation and remembering of variables through environment diagrams. And yeah, it's similar to a concept called memoization, where you can remember values so that you don't have to reference them, like, or recalculate them again in the future if you already have them known. You'll learn about that later in the class, but just good to hear some words, I guess. But yeah, did that make sense? Great. Very nice.
If there's anything else you want us to clarify, just let us know, of course.
But yeah, I mean, any more questions? If not, then we can proceed. But I would like to answer however many questions we have. So. Yeah, of course. Thank you all for coming. It honestly means a lot that it was I was able to help. And Sandhya, thank you for your help too. I definitely needed the help.
Yeah, of course. And thanks for hosting this session again. I hope it's been helpful to all of you guys.
But yeah.
Thank you.
Mhm.
Yeah,
I don't know if you guys still have time, but there was something that I saw in PyTutor and I didn't understand how this one step like jumped to the next step.
Mhm. You can go ahead and share your
For
screen.
sure.
Okay.
Though this will probably be our last question because I need to go get dinner.
Um,
Good old PyTutor.
it was from step 12 to step 13. I'm really confused.
Okay. Let's see how this works. I see. So essentially, what's happening is you notice that we were in the middle of evaluating line 3, right? In so F1 frame is actually running wait, is it? Yeah, it's running the yo function, yo with an underscore after it. And it returned rev of n comma -3, right? So that's its return value. The return value is whatever rev's return value is. So we execute rev on those following variables or arguments, and we get a return value of that lambda function that takes in an a. And the thing is, when we return it, that's the same one that we're returning here, if that makes any sense.
So it jumps back to the top in step 13 because it's calculating the result for rev.
Yeah, so we created lambda a in the underscore yo function, right? And that's our return value. We're returning that function. So that becomes the result of calling rev n comma -3. That result is being returned by yo underscore as its return value. Thus, a pointer is created to that same function, because functions are technically called objects. And instead of holding values, they hold addresses, aka pointers, to the same object rather than different objects that are, having the same data. Because of that reason, the pointer in F1 points to the return value of rev n comma -3.
Okay, thank you.
Yeah, I guess that is the end of this meeting. Thank you for coming. Thank you, Sandhya, for all your help, and I hope we can do this again another time.
Yeah.
Thank you.
If any of you guys have last minute questions, I can stick around for a little bit longer. But if not, then yeah, we'll see you guys another time.
Yeah, good
Okay.
night.
Always feel free to DM either of us on the Discord. I can always answer questions later, through just messaging or whatever. But yeah,
Oh, what are your guys' Discord IDs? Or is it the same as your name?
if you
Mine, I can just type mine in the chat. Yeah, you can also just ping the core staff role, the Discord server, if you have anything pressing. Because I mean, there's always going to be at least one of us online. Whereas CS majors, we're always on our laptops.
don't call me out like that. I haven't left my room in like a week.
I felt that. I'm gonna just lock in on IntelliJ right now, trying to finish that project.
I haven't started it. I have to do it tomorrow.
It's weird. It's a weird project.
Oh no. But yeah.
Have you guys finished Hog yet, or are you guys still working on that for 621A?
Oh no, I have not finished it. I just finished checkpoint 1.
Yeah, I remember Hog was interesting.
Does it get harder after checkpoint 1?
Hog was so much fun for me. Oh my god. The thing is, I had a partner, but I was so impatient to start that I just started and I did the bulk of the project by myself. And he was like, what the hell, bro?
Yeah, I would say Hog does get harder as you go on. I think for all the projects, the structure tends to be set up for the first few steps, and it sort of moves on to more involved implementations. But if you have a partner, that's really good to make sure that both of you have a good understanding of where you're at. If either of you are confused, and you guys can help each other, walk each other through the problem, try different approaches. yeah, the partner setup for section A is generally a really good one to stick with. So yeah, it does get harder, I would say. But as long as you and your partner are sort of like helping each other out and making sure you both have like a solid idea of where you guys are at, it's definitely like manageable to keep going.
I agree. Yeah, I mean, I worked with my partner in person every time. I would highly recommend meeting in person to work on it rather than through a call. I mean, if you really want, you can use things like Git, so you can be making changes and sending them to each other without having to both make changes at the same time. But I think live share on VS Code honestly works really great.
Yeah.
So
How did you guys meet your project partners?
I've known mine since high school. So
Oh wow.
yeah.
For me, I found a couple of mine through the forum. I'm pretty sure they would have done this year as well, but they would like post a forum of like people who were like looking for partners, and they would like pair you guys up. That and like later on this semester, I just paired up with people I knew from the class.
Oh, okay, gotcha.
But yeah, I don't think either of you have any more questions for now, right?
Yeah, I think we're good.
Okay.
Thank you.
Yeah, thank you for coming.
Yeah, of course.
It was really nice having you all. All right.
Yeah.
I will talk to you all later. Have a good one.
See you
Bye.
guys.